Welcome back to the Keaton Knife Shop. Today we're going to be making a small, lightweight, everyday carry knife that was highly influenced by the SE Azula knife. This knife should be lightweight and easy to throw into a bag or on your belt for your everyday needs. So the first step was to trace out the template onto a piece of 1084 bar stock and then cut it out with the bandsaw. After I had the rough profile cut out, we head on over to a 120 grit ceramic belt on the 2x72 inch belt sander to rough profile the blade. I find that a 120 grit belt works pretty good for this. Sometimes I used a lower grit belt, but I found getting those scratches out later was normally not worth the trouble. You can see here that I was able to utilize my new Origins Blade Maker's small wheel attachment. My wonderful wife got that for me for my birthday, and I've been using it on every knife since. It was a great addition to my shop, and I'll eventually do a full review on that small wheel attachment. So after I got the profile all nice and ground out, I went over and marked out where I wanted my holes to be drilled, and then drilled 2 holes with the number 12 drill bit. The number 12 drill bit size can accept 1/4 inch Corby fastener shafts, and we'll be using 1/4 inch Corby fasteners on this knife. And then mocked up with scribes all my grind lines. This here is the center line of where I'll be grinding my bevels to. I also have put lines on the side of the blade to show how high I'll be grinding my bevels and give me a target while I'm making these grinds. The belt progression on the pre-heat treat side was kind of all over the place. I was trying some new things out. I started off with a 60 grit ceramic belt and eventually worked up to a 400 grit J-Flex belt. And then just for fun, I threw on my new 220 grit cork belt to see how it would look after the 400 grit belt. I liked how it looked, and you'll see a little bit more of that later after heat treat. After I got the blade bevels ground out, I went on over to my idler wheel to take off some material on the handle, and then I took a chainsaw file to file in the sharpening notch on this blade. Just as a precaution, before the heat treat, I took some 220 grit sandpaper and really cleaned up the area by the sharpening notch, because some of those big file marks are hard to take out after the blade's been hardened. Before I went on to the heat treat, I made sure to drill my holes in my handle scales and also trace the outline of the handle out onto the handle scales, so as I can work on the handle while the blade is tempering. For this knife, we're going to be using 2 slabs, 1/4 inch slabs of ebony for the handles, and eventually stainless steel Corby fasteners. So I got the forge started up. I got my muffle pipe inserted into the forge, and then we go on to 3 normalizing cycles for this blade. I've only shown one here, but take my word for it, I normalized this blade 3 times just to take any stresses out of the blade after grinding. And then eventually, as you can see here, we quenched in canola oil, and the blade easily skated the file afterwards, so it's hard. So after I verified the blade was hard, we can put the forge up and go on to tempering. Before I put it in a tempering oven, I like to knock off some of the scale with a little piece of sandpaper and then clamp it up so that the edge of the blade is facing upwards. It will also be right next to the thermocouple that is currently running this tempering oven. So I set the tempering cycles at 207 degrees Celsius, which is around 404 degrees Fahrenheit, for 2 hours tempering cycles. In between tempering cycles, I cooled the blade to room temperature. While the blade's tempering, I was able to start shaping the handle scales. I cut them out roughly on the bandsaw, and then brought them over to the belt sander to start shaping the front of the handle scales. I took this angle to a 45 degree angle with a 220 grit belt, and then brought it up by hand to a 600 grit finish. I found the 600 grit finish looked pretty darn good on these ebony scales, so I stopped there. While the blades were still tempering, I went on to my granite block to get both of these handle scales nice and flat on the areas that will contact the blade or the tang. So the blade came out of the tempering oven, and now it's time to clean it up and get it to its final finish before I'll do my stone wash finish. So I brought it up to a 400 grit J-Flex belt in 2 steps, starting with the 220 and then finishing on the 400. I've really been liking the J-Flex belts because they can round over the corner of your platen and get into the plunge area and get all those nasty scratches out of your plunge. After I was finished with the 400 grit J-Flex, I moved on to a 220 grit cork belt, and it gave me this finish here, which I was pretty impressed with. I moved on to the hand sanding after this, and I found that the hand sanding only took me maybe 20-25 minutes in this case to get the entire blade up to a 320 grit finish. So I think it pretty much saved me about half the time by using that cork belt. So I have a 400 grit cork belt too, and I'm excited to use that one next and see where these cork belts can take me. After I got the whole blade up to a 320 grit finish with the Rhino wet, I went on to etch my maker's mark onto the side of the blade, and then I left the blade in ferrochloric acid for 9 minutes to etch the entire blade to a dark color. And then I took some baking soda and just rubbed it in all the nooks and crannies of the blade to make sure that acid is neutralized. Sprayed it down with some lubricant and put it into a bucket full of rocks. And then I shook this bucket full of rocks for about 4 minutes. Eventually I want to mechanize this process, but right now it's not worth my time. It just takes 4 minutes to shake it, so that's what I did. Moving on to the glue up, you'll see me using some G-Flex epoxy here. If you go back a couple weeks in my videos, you'll see I did a video on testing G-Flex epoxy versus the BSI mid-cure, and I was really impressed with the results from the G-Flex. This stuff is super durable and it can take a hell of a beating. So I got this knife all glued up. We're using stainless steel Corby fasteners. So the stainless steel Corby fasteners in conjunction with the G-Flex epoxy should yield a bulletproof handle that has years and years of use on it. Pretty much should never come apart. So I get the handle all put together and then take some time to clean up the front of the handle scales. Make sure there's no epoxy on the blade here with a cotton swab and a little alcohol. You won't be able to go back and clean that up easily after the epoxy is cured, so make sure you do that in advance. After 24 hours of cure time overnight, I cut off the heads of the Corby fasteners and then started profiling the handle down to the tang. I normally use a 120 grit belt to take away the bulk of the handle material before getting close to the tang, and then when I get really close I'll switch to a 220 grit belt so that the scratches I put into the tang are easy to get out. Then I'll do my initial handle shaping on the belt sander using these 1-inch scalloped belts. These are great. They don't gouge when you're getting into corners and radiuses, so I've really been liking those lately. And then I moved on to the hand sanding of the handle. I brought the whole handle up to a 600 grit finish. I started with a 320 and then eventually up to a 600 grit finish on the ebony scales here. After I get all the hand sanding done on the scales, I'll head back over to the belt sander and then just clean up the entire spine, because half of that spine still had some stone washing on it, so I wanted to get the whole spine to a satin finish. After that was accomplished, we went on over to the Kydex press, heated up 2 pieces of Kydex, and formed our sheath. I was going a little slower than normal here, but it didn't make that big of a negative difference, so the sheath still came out great and it conformed to the contours of the knife. One thing I'll note is when I'm taking the Kydex out, I try to make sure to get my fingers in there and push down on the sheath. This generally aids in keeping the 2 pieces of the sheath together. If those 2 pieces come apart, I find the next couple steps to be a little bit more cumbersome. So the 2 sheath pieces stuck together, I was able to mark out where I want all 6 of my holes, punch all those holes, and then drill out those holes with a 1/4 inch drill bit to accept which is the right size for the eyelets I'll be using. I then mock up the profile of the sheath, cut it out with the bandsaw, and then go on to the grinder to get it all nice and cleaned up to my lines. I'm using the 2-inch idler wheels on my flat platen to get the radiuses on the front or on the top of the sheath, and I found this to be a pretty good size for doing so. Now notice this first eyelet I kind of destroyed there, but in general I've really enjoyed having this arbor press with the dies from DIY Holster. They've been doing a great job. I went back and I cleaned up that eyelet, but it's very rare for me to crush an eyelet on that arbor press. I then took the knife to the belt sander and put an edge on it with a 400 grit belt, and then stropped it on my leather strop. Got the knife nice and sharp, and it's pretty much good to go at this point. So this is how our little everyday carry knife turned out. It has ebony handle scales with stainless steel Corby fasteners and a 1084 blade steel. It's lightweight, small, compact, easy to throw in a bag or on your hip. I hope you liked the build of this knife. If you did, please go ahead and hit that like button below. And if you want to see more videos like this and also tool reviews and just other knife related videos, go ahead and hit that subscribe button down below and you'll be able to see all the content that I post going forward. Until then, I'll catch you guys on the flip side.